Hey, pre-calc, check out the do now for today. A coin has been flipped 6 times. I want to know what's the probability of getting 2 heads and 4 tails. Go ahead and hit pause while you work this out. Well, so 6 coin flips. We got to look at the 6th row of Pascal's triangle. I've got that highlighted in yellow. And then we can take a closer look at how to do the rest of this. But I'm going to count across that row, starting from 0 successes. You could count successes as either heads or tails, whichever way you feel. It doesn't actually matter. But so 0 heads would be 1 outcome. Getting 1 head is there are 6 outcomes. Getting 2 heads, there are 15 outcomes. So 15 is the number of outcomes that give us that 2 heads and 4 tails. And then our probability would be 15 out of 64. Okay, where'd the 64 come from? Well, I broke this apart into smaller bits. So we got the 15 outcomes we just talked about. 2 to the power of 6. It's going to give us the size of the sample space on 6 coin flips. Each coin has 2 sides, 6 trials. So that's going to be our exponent. It gives me the 64. That's the denominator of my probability fraction. Always reduce if you can. 15 over 64 is not going to reduce. So there's our final probability. Okay, well, today we're going to continue our journey through statistics and learning targets still not changed. Be able to use counting methods to determine probability. Counting methods, pretty inclusive term. So we'll look at mainly two, I guess, depending on how you count, 2 additional strategies for today. So first, let's just do a little bit of thinking. If you flip 6 coins, what's the most likely outcome? You probably just don't even need Pascal's triangle at all. I could cover that up. I think you'd probably maybe even do better. I mean, 6 coin flips, probably you're going to get how many heads? Probably 3 heads, right? Or probably 3 tails, same thing. But we see the exact same thing here by looking at Pascal's triangle. Which one has the most outcomes? Is that one in the middle? There's 20 outcomes that give us that particular outcome. So if we just count across, either using heads or tails, doesn't actually make any difference. 0 tails, 1 tail, 2 tails, 3 tails right there in the middle. Label the rest of them. If we'd counted with heads, it'd be the same thing. The one in the middle is always going to be the most likely, right? Or the one that has the highest number of outcomes. If we have a list of outcomes, like we see here in Pascal's triangle, whichever has the largest number associated with its outcomes, or it's also called the frequency, that is going to be most likely. So right there, highest frequency. Frequency just means how often something happens, right? So if there are 20 outcomes that give us the 3 heads and the 3 tails, which is more often than any of those other individual outcomes, it's going to happen more often. It's got the highest frequency. What is the total number of outcomes for 6 coin flips? Hopefully remember this because we just did that a second ago. 2 to the power of 6 will tell us that is 64. So if I was to ask you what's the probability of getting the most likely outcome, which we've already said is getting 3 tails and 3 heads, the probability of getting the most likely outcome is going to be 20 out of 64. Always reduce our probability fractions if possible. So in this case, because both of those divide by 4, 20 divided by 4 is 5, 64 divided by 4 is 16, so 5/16. Both are correct, but we always want to reduce. All right, well, let's look at this thing called the addition rule. So here's an additional counting strategy. We'll see 2 of them today. So here's one. If you flip 6 coins, I'll just stick with this example. What is the probability of getting at least 3 heads? Whoops, missing word. What is the probability, missing 2 words, of getting at least 3 heads? Well, we just did the probability of getting 3 heads, but this is a pretty important set of words right there. At least, well, what does that even mean? At least 3. That means that we could get 3 as the minimum number that is acceptable, right? You could get 3 heads. That would answer this question. But also, you could get more. 4 heads, that's more than 3, right? If it says at least 3, then it means there's actually multiple outcomes that satisfy this question. So 3 heads, 4 heads, 5 heads, 6 heads, any of those represents 3 or more, right? Another way of saying this, at least 3 means 3 or more. So I need to find the probability of getting 3 heads, the probability of getting 4 heads, the probability of 5 heads, the probability of 6 heads. I'm going to combine those using, you probably guessed this already, addition. So just add those together. That'll be the total number of outcomes that give me at least 3 heads. Let's see if we've got enough space to write this down. So probability is going to be 20 plus 15 plus 6 plus 1. That's going to be my numerator. 35, 42. All right, so there's our probability fraction, 42 out of 64. We're going to reduce that. In this case, divide both of them by 2, so I'm going to get 21 out of 32. For some people, you prefer decimals, percents, whatever. That's totally fine. I'm going to leave it in fractional form, but that is the addition rule. So if we have multiple outcomes that satisfy the requirement of what we're looking for, we can add those together. What's the probability of getting anything else except 3 heads? All right, well, we can do the same thing. So what's the probability of getting anything at all? Well, that'd be 100%, right? 64 out of 64, but that's not what it says. What's the probability of getting anything at all except not 3 heads? There's a couple of ways you could do this, right? One option, we'll just do straight addition. So not this one. We'll just add up all of these. 1 plus 6 plus 15 plus another 15 plus 6 plus 1. That's going to be our numerator. Put that out of 64. Okay, so 1 plus 6 is 7 plus 15 is going to be 22. There's the same numbers again over here. 15 plus 6 plus 1 is another 22. So it's 44 out of 64. Okay, so the addition rule we can also do backwards. We can do the subtraction rule, right? So if the question says, what's the probability of getting anything, except not 3 heads? Well, the probability of getting anything at all is 100%. So 64 out of 64, right? Except not 3 heads. Well, if 3 is not, the 3 heads outcome is the thing, we got to take that out. That's not actually part of our answer. So I could just subtract the 20 off of my numerator. 64 minus 20 is still going to give me the same 44 out of 64. So addition rule, or depending on how we want to think about it, subtraction rule. If you start with everything, you can just take out the stuff that's not included. Okay, same thing. We still need to reduce that fraction for our final answer. So let's just go like this. Okay, final answer over here, divided both by 4, so I'm going to get 11 out of 16. All right, what's the probability of getting either 3 or 4 heads? All right, well, that's these two. Add those together. 35 is the numerator. There's still 6 coin flips, so I'm still out of 64. All right. Well, counting strategy number 2. There is a better way, aside from using Pascal's triangle. Better, I'm going to put in quotation marks. There's another way. And if we're doing something like what we just looked at, those examples of like anything else except for 3 heads, maybe actually Pascal's triangle is faster because there's a lot of things that I'm going to need to add together. Possibly. Okay, well, you can just calculate any number anywhere in Pascal's triangle without having to like create all of those rows of Pascal's triangle and count. Oh, I got to get to row 6, 1, 2, 3, count down to row 6. Oh, then I got to count across to get to where 2 heads is at. 0 heads, 1 heads, 2 heads. So this, it's a lot of tedious little like identifying which row and which number in the row. So you can just calculate it using nCr. It's a calculation in your calculator, and n is the number of trials. So in this case, that's going to be 6. There's 6 trials. The coin is flipped 6 times. R, we're going to call the number of successes. And you could say getting heads is a success. You could say getting tails is a success. Does it make any difference? No, we have no idea. So you pick one, either the 2 or the 4. We're going to get the same thing because Pascal's triangle, we saw this already. You count across from the head side, 0, 1, 2 to get to 2 heads. Or if you count from the other side of Pascal's triangle with the tail, 0, 1, 2, 3, 4, you end up with the same place. So it doesn't make any difference in this calculation either. You pick the 2 for the 2 heads or the 4 for the 4 tails. Just don't use both. Let's get this set up. So 6C2. It's going to look like this. This is how we write it. The C is a big C, and then both the 6 and the 2, regardless of what numbers they are subscripts. It's kind of like the opposite of an exponent, so we write it small and a little bit lower than that C. So it's not like I'm just being sloppy and that's the way it comes out. That's the way it's supposed to look. The N and the R are always going to be subscripts. Okay, so on your calculator, you're going to need to type in the 6 first, depending on your calculator. Maybe it's a little bit different. On your Texas Instruments, TI-83, TI-84, any of these, you're going to want to get that 6 on the screen first, and then we'll go through some menus to find where the nCr button is, and then after we get that, then we'll hit the 2. Okay, so right here is a button called Math. That is where we're going to find nCr. So you hit Math, and then it's going to pull up like a drop-down menu. You're going to have to scroll across using the arrow keys until you get to Probability, and then you can use the up and down buttons to get to this option right here. So in real life, here's the Math button. Okay, so I'm going to, before I hit that, I want to make sure that that's 6, my N number, the number of trials, that's going to go on my screen first. And then I'm going to hit Math. Here's my drop-down menu, so I need to move right to get to Probability. If you like, you can do the opposite. You just hit left once, and it'll like circle around the other direction. Little shortcut. So get to Probability, PRB or PROB, depending on the version of calculator, might be abbreviated differently. And then arrow down to option 3, or shortcuts, just hit the 3 on your calculator. It'll jump straight to nCr. But I'm going to demonstrate with the arrows here. Okay, so my mouse is hovering over, or my cursor is hovering on the 3. I need to hit enter to put that into the screen, out of the menu and onto the actual calculator screen. Now I'm going to finish typing in my calculation. So I wanted 6C2. The calculator puts nCr because it's just the way it looks on the calculator, but we don't actually say the N and the R in this case. It's just 6C2. And now I can hit enter to get the answer. It's going to be 15. All right. Let's see what the other one is. If I chose to count the 4 tails, let's do 6C4, 6 Math, over to Probability. Option number 3 puts the nCr on my screen. I'm going to do 4 this time, hit enter, and it is the exact same answer as it should be. Okay, now sometimes what happens is people will forget to put that 6 in there first, or whatever number your number of trials is. If you do that, here's what's going to happen. I'll demonstrate the error. So if I hit Math, Probability, down to nCr, hit enter, blam, and it's going to pull the previous answer. Whether that's something I can see on the screen or just the previous answer from last time I had the calculator on. So in this case, it's going to use 15. That was my previous answer. So this will be 15C2. That'd be like 15 coin flips. What's the number of ways I could get 2 heads if I flipped 15 coins? Well, that's not actually what I want, and it's going to give me a totally different answer. So we got to pay attention. Make sure you get that N number typed on there first. All right, well, let's practice a couple of those using your calculator. Let's find these probabilities. Try using nCr on your calculator. Let's just follow along, see if you can get the calculator to do the things you want it to do. So coin is flipped 10 times. What's the probability of getting 6 heads? Coin is flipped 10 times. What's the probability of getting 4 tails? And coin is flipped 12 times. What's the probability of getting 7 heads and 5 tails? All right. Well, to get 10, that's going to be my N number. 6, that's going to be my R number. So I'm going to do 10C6. That'll give me the numerator of my probability fraction. And to get the denominator, they're coins. Coins have two sides, and I'm doing 10 repetitions. So 2 to the power of 10 will give me the size of the sample space, or my denominator. And get rid of this stuff. 10 C 6. That's 210. 2 to the power of 10 is my sample space. So 210 over 1,024. 210 over 1,024. And that was supposed to change colors. Oh well. Okay, so there's our probability. That I can see will reduce. Both of those numbers are even. So if I divide them both by 2, I'm going to get 105 over 512. All right. Coin is flipped 10 times. What's the probability of getting 4 tails? Well, I could do 10C4. But I know that 4 tails is actually the same thing as 6 heads, because if there are 10 coins and 6 of them are showing heads, what are the other 4 doing? They got to be showing tails. This is the same thing. We can do it on a calculator just to prove it to ourselves, but I'm going to get 210 over 1,024, just the same as I did last time, and that'll still reduce. All right, last one. Coin is flipped 12 times this time. What's the probability of getting 7 heads and 5 tails? 7 heads and 5 tails means the same thing. There's 12 coins. The number of heads and the number of tails have to add up to make 12. There's 12 coins. They've all got to show one or the other. Pick one, either 7 or 5. Use that for your calculation. It doesn't matter which one you pick. They're both the same. So 10C7, I'm going to do that one because it's listed first. And then for my denominator, 2 to the power of 12. And calculator says 792 over 4,000, what is it, 96. And so is my probability. That's correct. It can be reduced. If I reduce that, I think I can divide everything by, definitely by 2. I do that, I see I can divide them again by 2, and then I still end up with even numbers, divide everything by 2 again. Or if you'd rather just reduce all at once, if you can figure this out, you divide both of those by 8. Final reduced form here, 99 over 512.